Yes.
Okay, fantastic. So,
Excuse me. It's
does anybody have any idea what this class is about?
Technology, cybersecurity, and policy.
I can't hear you. Could you say it a little bit louder?
Technology,
Technology, cybersecurity, and policy. Technology, cybersecurity, and policy. So, how many of you have ever heard of something called MUSAC? MUSAC. Maybe 5 of you. How many of you ever heard of a company called Netflix? How many of you have therefore heard of streaming video? Ah, okay, good. So, technology, cybersecurity, and policy. Our speaker today is Alex Woolford. Did I pronounce it correctly? Alex is with a strange company called?
Confluence.
Confluence. I have no idea what Confluence is, but he's going to tell us, and he's going to tell us about streaming technologies, and streaming technologies are intimately related and engaged with cybersecurity and policy. At the end of this semester, you guys are going to all hate me, but that's okay. Please welcome our speaker, Alex Woolford, technology, cybersecurity, streaming data, and Confluence. Welcome.
Thank you very much.
Thank
you. Hi, everyone. Thank you. Don't clap yet.
No, they have to pretend like they have social skills.
All right, very good. Good job. All right. So Confluent means the coming together of streams. And when I say streams, I mean, what happened there?
Yeah, it just went.
Screensaver. So let's plug it in. Maybe. Is that?
Yes,
Sorry about that. Okay, yeah, we're back on track. All right, so it means the coming together of streams. It's got nothing to do with streaming video. So these are events in businesses. Yeah, so this is kind of a quick agenda. So there's a bit, who am I? We're going to talk about IoT. That's a massive, 5G is coming out. Well, it's already out, and it's super fast, and it's driving a lot of IoT type use cases. This is going to feel a little bit like speed dating for technology. So I've got a few geeky demos that I can show, and so we're not going to be able to go deep on any of them, but hopefully, we'll throw, 5 or 10 technologies at the wall, and one of them might stick, We're going to have a quick look at a SIEM type use case. Everyone knows what SIEM is?
No.
Oh, okay. Security Information Event Management System. This is like a Splunk type thing. Changes in the industry. GPU is very hot. Everyone's heard of NVIDIA, I'm sure. And it was just a graphics card, but it's used a lot more for math these days than graphics. And these are things that I've done, a couple of examples that amuse me, and then just a quick note about privacy and so about me, make this nice and quick. I come from the worst place in England. It's called Slough. It's like the New Jersey of England. And
Oh, not fair.
no. Yeah. And that's an actual picture from Slough. And so I'm growing up in Slough, and I thought one day, I've been dealt a bad hand. So let's get out of Slough. And so I ran off to India. So look, I was skinny once. And then I met the lady at the back, who's the wife of my wife. So, never mind. Yeah, it's a real 2000s thing. And that's my wife. And then we procreated, and we have some offspring, and these are cute ones.
Wait, these are the cute ones?
Yeah. And then along the way, I became a supply chain guy, just almost by accident. I sort of copied my brother, and then I've got a penchant for technology, so I ended up drifting off into big data. So I've been working in the big data space since, well, probably for about 8 years or something like that. I used to work for Hortonworks. They are now Cloudera. Back when Hadoop was cool, it's not cool anymore. And then I went to a company called Streamsets, which I will show you what that does. And now I'm at Confluent, the coming together of streams. Anyway, so earlier on we mentioned 5G. Look at, this is the speed, megabits per second, and this is typical usage. So a new standard comes out about every 10 years. This is crazy. This is a crazy leap in speed. And this is kind of not the whole story, gigabit. So you can get gigabit on 5G, and it's driving. So this company, IHS, Information Handling Services, they're like a kind of a thinkers that you pay money to get reports, and so they have people on staff who write papers, and people think they're significant. So they came up with this. This is their data, and look, transportation has grown like crazy. It's projected to grow like absolute crazy, and a lot of this growth is going to come from the connected car. So every car manufacturer, we personally, Confluent, and I'm speaking as myself, incidentally, so nothing I say has anything to do with my company, just in case. But Audi and GM, they're big into the connected car. Audi are a Confluent customer, and look, these are all the sort of different types of use cases, and I think there's some kind of creepy ones out there. So I'm thinking of like usage-based insurance, for example. You put a dongle in your car, you have like an OBD2 port in your car, and the insurance company can tell if you're driving like an arse. And they can, so this, combined with where you are, I think they can put it together and learn quite a lot about you as a person. So I'm thinking, if you stop at a bar and you stay there 2 hours, you've got your lat-long sort of car hang around in the car park, and then you've got some safety thing inside that's doing like lane departure, and then probably they want to up your rates, and you don't know why. Yeah, there's a lot of interesting use cases in the connected car space. So this is the founder of my company. He worked at LinkedIn, and LinkedIn had this data integration mess. So they had all of these like sources and destinations, and then each one of these is like a point-to-point connection. And that is really, really hard to manage. And it's an n-squared problem, right? You add more things, and it just gets more, the network gets saturated, and it's really hard to manage. And so my founder came up with this idea, why don't we just put a log in the middle? So this is what Kafka is. It's a unified, distributed, it's a continuous commit log. And this came out about 2011 at LinkedIn. And it took off. It's really quite popular, and then he kind of like spun out, and we all hope to get rich from this idea. You know, that's the Silicon Valley dream, isn't it? So this is what we call the 4 Comma Club. So you mentioned Netflix earlier on. They do actually use Kafka, but they use it for things like, how far did I get in the movie, or you know, all my actions, my clickstream. This is clickstream data, and it's 2 trillion. That's an insane volume. Like I always used to hear B's, not T's. So I think that's really kind of amazing. Lyft is one of our biggest customers. Uber used the open source version, and so there's, you know, so it's like lots of companies have this model, right, where you have some tech, and then you have like a proprietary bit and support and all that. Anyway, 4 Comma Club. So today, I want to touch on, these are popular technologies. We've got an Apache managed section. Everyone familiar with the Apache Software Foundation? Yes, okay, right. So I want to touch today on these. These are GUI tools, right? Streamsets and NiFi are kind of GUI. I thought that would be a good place to start because I don't know where everyone's at code-wise, right? So, yeah. But then these things here are all like stuff you typically write in Java or Scala or something like that. And this is getting a bit long in the tooth now, but it was cool a few years ago. So, we're going to have a quick look at these things here. So the first thing I want to touch on is this guy wrote a book, and I bought it, and I was so sorry I bought it. It was really boring. So he's from the 1970s, this guy. And so at IBM, he was like a thinker at IBM, and he came up with this idea, like, I draw stuff on a whiteboard, look, and this is an actual thing. You draw, this is ALPR, is a license plate reader. The use case here is a law enforcement agency on the East Coast, and they want to do things in real time. So they have, over this big city, they have cameras everywhere. They're generating little XML messages and that have like a little JPEG, and they send them back, so a stream of messages. And then they have this thing called a hot list. These are all stolen cars, or someone, Amber Alert, those types of things. So this hot list ends up being in Redis, and then you have a couple of like relational databases in there, and then you have a stream, and actually this forks into different topics, and people take action in real time. They have this thing, I think it's going in Denver, there's a thing called ShotSpotter. Have you heard of it? Anyone? Yeah. No? So, yeah. So they put they look like pillows. They have like a stick that looks like a pillow or a balloon on top. They put them on top of all the buildings, and then when a gunshot goes off, they can triangulate where it is. And latency is obviously very important if there's gunshots. They have like an ML model that sort of does that. I think it's quite clever. But anyway, flow-based programming, what you draw on the whiteboard ends up being what goes into production. One thing I really like about this, right? Is that an anti-pattern? Works for me. So what I like about this is technical debt, right? So when you first implement a use case, it's quite quick to get it out the door, usually. And then the next use case, you want to make some change. Someone doesn't really know the code base, and the guy who wrote it's left, and it doesn't look, the structure of the thing doesn't look anything like this anymore. It's all like a myriad of classes and just like, ugh, So this allows you to iterate and work on more new things than maintaining old things. So anyway, here are 3 examples of this type of technology. Streamsets, which is where I came from, NiFi, which is where I came from, and then Node-RED. This IBM thing. It's very lightweight, runs on like Raspberry Pi or Edge devices. It's worth a look for very lightweight things, Node-RED. And if you go to like a Strata or a Kafka Summit or any one of those conferences, you'll see like a gazillion vendors selling this stuff. And that's because, well, it's a good idea. So I want to show you a quick example using Streamsets. So that, come on, let me out. So Streamsets, this is Streamsets. So I'm going to call this weather. And basically what you've got here, you've got a canvas of origins, destinations, processors, and executors. So if you want to build a pipeline, I went to one of my favorite websites, which is Programmable Web. If you're looking for an API to integrate with something, there's 22,000 odd, and you can just search for what you want. And a lot of them you have to pay, or there's some reason not to use them. But if you fish through that, you'll find often what you're looking for. So I have a URL here. And what I'm trying to show here is that it's easy just to very quickly set up a feed. So this is a URL. And I'm going to have an HTTP client origin here. I'm going to slap that URL in this URL box. Polling. So we're going to poll, and we'll say we're going to poll every 5 seconds, and then we're going to write that out to Kafka. So let's type in here Kafka. And I know this is tedious, but we're almost done, so don't worry. So let's say which Kafka I'm running, a recent one. I'm going to give it my broker, one of them, just for now. And throw the errors away. You would usually have a dead letter box. If you were putting this into production or something like that, you would have like a dead letter box to get rid of, so that errors go somewhere. And that's it. So in a moment, we should start to see, messages flowing through. And then if we pop over to Kafka, well, actually, you can look at them. So this is kind of a nice feature. I can say capture snapshot, and usually there's more traffic than this. And this is a bit like taking a sample out of the stream. You can eyeball it, and you can see how it changed. So if this pipeline was very long, it had a lot of steps, you could kind of like bounce through the steps and do a sort of debugging, if you like. So in here, look, here's the here's our weather record. And if I looked in Kafka, we would see that being output as JSON. But anyway, that's like Streamsets in as quickly as you can show Streamsets. Any questions? Or yes?
So the benefit would come if there was many, many more data sources going into the Kafka producer?
So Streamsets is one to many. So you always have one origin. If you want to combine data sources, then you would use a different technology. You would probably use, like me personally, I would use Kafka Streams for that, or KSQL. There's something called KSQL, which allows you to use SQL-like semantics on streams of data and do those joins and things like that.
Okay, I guess I was thinking more about the earlier slide. LinkedIn had the many sources go into many sources, and you put the Kafka in the middle.
Yeah.
And so, what is it? What it look like?
Yeah. So that's one topic. In fact, I think I forgot to set the topic name in this. But look, if you look at this configuration here, go to Kafka. Yeah, I forgot to change the topic name. But this thing here, you would say weather, and all of the weather messages get posted to this, and then you'd have lots of different sources, and they all end up in the same place, and you can build applications on top of them.
Okay.
Yes. All right, back on this thing. Okay. So when I first started doing this, people would ask me like, oh, I want to build a pipeline, and I need to get CDC, change data capture from MySQL, and I want to output to these different things. And I thought, oh yeah, that's easy. Bam, 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 set the properties, hit play, voila, it's working. And then I walk away and I get a phone call like, 2 weeks later when they're doing some maintenance on InfluxDB, and they say to me, oh, that thing you built is broken. And I'll be like, oh, really? And then it turns out it's all my fault. And the reason for that is this thing here is taking a little batch of records, and there are delivery guarantees with this, and it's making sure that it delivered them to all the locations before it says, okay, I successfully did that. Now, if this thing goes down, that's broken at that point, and so it can't keep these records fair. It tries a few times, and then it barfs and just falls over. And so this is an anti-pattern. So what I would recommend is always write stuff to Kafka, or Kafka's not the only messaging system. There's Amazon Kinesis, there's Google PubSub, there's a whole bunch of them. But write them to a message queue. I would recommend Kafka because I work for Confluent. And then have separate pipelines that go to your other things. Yeah. So that's kind of like my 2 cents if you do this yourselves. So everyone's heard of change data capture, or do you know what that is? Yeah, everyone? Is that like, maybe it's too kind of basic, but I just thought this was a good chart. When people say to me, I have a gazillion different systems that I want to integrate, what should I use? What I'm supposed to do is tell them, oh yeah, use this one. This is a bit expensive, a Tunity, but look at the coverage. If you have that, you can connect to pretty much everything. And like the the drag and droppy data streaming space, this has a ton of players also, so it's getting a bit competitive. That's good. It drives down prices. I personally like Debezium. Debezium, I think it's owned by Red Hat. That's an open source thing, and it's I think it's a pretty great solution for free, at least. Yeah. So I want to show you a quick example. Maybe everyone knows what CDC is. Is that like a dead example for this group? No, you want to see it?
Yes.
All right. Okay. So I think NiFi. So this is Apache NiFi. So this came out of the NSA. This project is about 10 years old. Question? Yeah.
What are the different colors? Red, green?
That means they do it, they don't do it. So green means go. I can do my CDC for this technology with that. Yeah. So NiFi, it's a bad pun. Niagara files, that's horrible. So, but they have these things called flow files, About a decade ago, the NSA were collecting information from all over the place, and they were using this. I don't know if they still are. And then they open sourced it. Then three companies ago got hold of this and said, oh, look, we can sell it. That's brilliant. And here's how you do change data capture with it. So on the MySQL, this example is MySQL, and it doesn't really have very good change data coverage, but it's just an example. Like the other thing, it has a canvas. You can search through all sorts of different processors, 293 they claim. I think that's kind of amazing. But then I type Kafka, and then I see, look, there's 20 odd just for Kafka, and I was thinking, well, it kind of needs 2, really. So that 293 is a bit of a sort of false boast, but it's still cool. They still have a lot of things in there. So all I had to do was set a few properties in here. So if we go into the properties, the usual things, the host, where the jar, username, password. I tell it what the schema is and the table in this case. So I've got this schema that I've set up, and I'll insert a record. Let's pop over to console here. This is my machine. Let's make sure we're still connected. Can you guys see that? Or is it?
Yep.
Did my VPN break? I think no, that's very strange. Oh, I think this might have just gone sideways. Let's try and log in again. Oh, crap. All right. So here's what you're supposed to do. You're supposed to imagine a record. When I insert this record, you're supposed to imagine it appear in Kafka. But I don't know why I can't log into my... I don't know what happened, and we have to move on. I'm sorry for that. All right. So, anyway, meanwhile, that's NiFi. So let's get back to this. So, there's something called the Strangler Pattern. Anyone heard of it? Strangler Pattern? I think this is a really cool idea. There's this fig plant that in jungles grows around trees, and so this is kind of the idea. Imagine you walk into Costco and you see, how are they using an AS400 in this day and age? That's crazy, right? But they run their whole business on this ancient thing, and if anything happens to it, it's mega disaster. That's like a SEC type event. So. The idea is that you'll put something, there's a company called SyncSort that makes CDC for mainframe. You'll put SyncSort on the box, and then you can get all of this data out, and you can start to build other things around it. So you can drive your website. So a website, this AS400 has this thing called MIPS, millions of instructions per second, and they're often allocated. There's only so many to go round, and departments get billed. It's something that's scarce, and you need to not burn all the MIPS on frivolous stuff. So anyway, you put SyncSort on here, you get the data into other things, and then eventually, this is kind of a dream state, right? You've kind of freed yourself from your AS400, but that's the general idea. The Strangler Pattern, and it's named after this fig plant. So the Strangler Pattern, you've probably come across all sorts of different databases. But I just thought I'd mention that when you have a use case, the access pattern of the data should determine what database you use. So Elastic is fantastic for searching document databases, right? So maybe you take your data from your AS400 or whatever, and you split it up into, maybe use a Redis cache to speed up some application. You have something that is making expensive calls against some database. You stick Redis in front of it, and you're going to sort of give it some breathing room. So, and for every flavor that's on-prem, these are sort of the on-prem things, there's cloud services for all of that, except for Graph. Couldn't find one for Graph. So if anyone knows of the cloud for Graph, yeah. All right. So this is where we're at. I just thought this is a sort of signpost so you guys know, we're getting there. next thing is the Security Information Event Management System. This is kind of like a suggestion. I'm not saying this is like a fully baked solution, but it's an idea. It's how you would go about taking all of these events, you put them into something, and then you can transform them and do something useful. So in my house, actually, I have a Fortinet firewall, and look, it's so easy to point it at a load balancer. You don't need to see that. You just log into this console, you just say, give it the host name, and then you hit this load balancer here. The tricky thing that I thought, when I first did this, I thought, oh, that's great, I've load balanced UDP. So UDP, I can't remember what it actually stands for, but I think of it as Unreliable Data Protocol. And if anyone else knows the real thing, what is it?
User datagram protocol.
What is it, user?
Datagram protocol.
User datagram. I think unreliable is better.
Yeah.
It's when I first switched this on, I thought this thing was just going to magically heal, and then I realised it's fire and forget. This has no idea whether or not the message was received, and so I thought this was kind of neat. You have Nginx load balancer, and you can do a health check against the process that is ingesting stuff downstream. So in actual fact, you've got this like thing behind the scenes, and it will drop this out of the pool if it fails this health check. So it's just doing a call, like, call 8073, this URL, does it have the string running in it? If not, kill it, no more traffic goes there. So that's kind of the secret to load balancing UDP. I don't know, I liked it, yeah. So on the same vein, we've got OS Query. Has anyone heard of OS Query? No, all right, good. I'm so glad, because at least this is a real treat. When I first saw this, I thought, well, that's kind of neat. And then I started to think about it, and I thought, wow, that's actually a wild idea. So Facebook, this thing is so lightweight. You run it on all your servers, your Mac machines. It's used by Palantir, who I think are kind of evil. I hope no one has anything to do with Palantir. But this is good tech lineage, all of these companies here, and they all use it at scale. And they use it to collect information. And so it exposes all of the OS type things as SQL. And everybody knows SQL. And then you can take that and you can get it scheduled that so it goes into Kafka. And then once it's in Kafka, you can do whatever you want with it. So this is a really neat thing. I just want to show you roughly what it looks like. So I'm going to log into one of my boxes here. Here, look. So there's an interactive thing. Oh, can you see that? Do I need to? Is that better? OS query I, oops, with a Y. And if you type .tables, these are all the tables that you can access. So there's all kinds of things. And I was thinking the other day, I got my syslog data going through my firewall, and I was thinking, oh, well, that's really kind of interesting. I can see stuff in my house talking to Russia, and I'm thinking, why the hell is stuff in my house talking to Russia? And then I don't really know what is talking to Russia, right? I just know it's going through my firewall, and I wish it wasn't. And so then I was thinking about this thing. What if? Here, I'll show you a query I wrote. But I think it's kind of a neat idea. So look, you can start to join all of these tables, and hopefully the resolution's all right, so it won't look so ugly. Yeah, it's all right. So what this has done, oops. So we've got a select statement here, and I just joined the processes with the users and the open sockets. So now I can see, this is the IP address. This is the Java process. This is the user using that IP address. I can start to put those things together that I wasn't able to put together. And that's more than just like having your syslog data and sticking it in Splunk, right? You can start to combine the things, and it's a good idea. Yeah, so that's OS query. So worth a look, yeah. All right, so back on. 1 second. Right. So one thing I have been doing for quite a while, I find this kind of interesting that you can take an IP address and you can figure out the lat long of it. And I started to use this, and actually you can start to overlay things with demographics, right? If you know the lat long, then you know the town, and you know the demographics of the town, and you can start to build out things for data science, right? So I thought it's quite interesting, and I'm reading up on it. And then it turns out that you have to pay attention to the radius of the accuracy. So there's this poor farm in Kansas, and if it just knows that it's in the United States, it puts a point in the map on this farm in Kansas, and so people are out there looking at kiddie porn or whatever, and then these guys get constantly woken up. They have so many weird things happen in this little farm in Kansas because of this point on the map. I thought it was kind of funny. So that is an actual toilet that was left outside, and they're just like, their whole life is just full of weird things because of this point on the map. So now what they've done is move that point into the middle of the lake. So when the FBI go running down there to bust someone, they're like, oh shit, it's a lake. Yeah. Anyway, yeah, this, has everybody seen Hot Dog Not Hot Dog? Yes, right? No. No, oh, no. Oh, it's such a classic. That's an app you can actually download. So in Silicon Valley, it's a TV series based on tech, and it has this guy builds an app, and it's using GPU, and the idea is I can detect any type of food, and he goes up and it's like, look, pizza, and then it's like, and it says not hot dog, and they're like, oh. But the point is GPUs is kind of getting very, very popular. Notice this graphics card, right? It's a graphics card. This thing is 10 grand. There are boxes where people have 16 of these in one box, and you can hire them on Amazon, and it's like, I was looking, like $20 an hour or something like that. So imagine how pissed off your company will be if you left it switched on, you know. But they also have little edge devices. This is $100. So if you want to do kind of like GPU type things on the edge, you know, $100. It's a freaking bargain. Yeah, so I want to show a kind of like silly example of this. So my point is, look, there's data all over the place, and maybe you can tie into different sorts of feeds and do something interesting with it. So the other day, I kind of like grew up in the 90s, so you might remember this film. But I was thinking, look, why? Can you see this? I don't have the audio, but look. I made a little Python program. This is just a few lines of code, and it recognizes all the actors. And it's something you can do at the edge. You can take everyone's face has like a fingerprint. If you can stream that, then you can put it a little bit like the New York Police Department where it has the hot list. You can have a hot list of faces. And companies do this, and sometimes they get into trouble because people look like other people, and then they get arrested and stuff, and it's not cool. But it's an interesting thing you can do, and it's very easy to do. I don't know if anyone cares about the details. And excuse the crappy code, right? This is horrible. I know I should have put all of these pictures in a folder and had yeah, it's horrible. But look, you have a bunch of faces, and then you go frame by frame and you go find them and you label them, and that's it. So you can send those as messages. That's the point. And GPU enables that. Yeah. Right. So that got me thinking about, you know, I like electronics. Oh no, yeah. So, oh yeah. I think this is. So the GPU also enabled people to build machine learning models. You can parallelize things and go so fast. I was using R, you know the language R? It's not very cool anymore, but it was like 5 years ago. And there's a thing called GPU tools, and I was running this like linear regression thing, and it was taking like 3 minutes. I do the GPU tools version on the same box, and it's like 1 second. It was incredible, and so I'm a bit in love with the GPU. Anyway, so this thing here, H2O, has anyone heard of this? H2O? No? Okay. It's a machine learning framework that is very, very, very easy to use. It has different APIs. You can use Python or Java, or there's even a notebook type thing. And what you can do, you can take, collect your data. So this is something that you collect your data, you enrich them. You've got your IP addresses, you add up, you pull in the other metadata, you stick it somewhere, and then you run this little H2O tool. It builds a model for you, and then you can take that model, and then you can put it in the stream of events, and then you can do actionable things in real time. So I'm thinking, like, imagine you have a call center, and you might have someone who's going to churn. They're an angry customer. You can see your model says by your prediction, your sequence of events, this guy is pissed off, he's going to leave. So maybe you don't give him to the brand new person on the phone because they're just going to say, oh, I don't care, sir, and hang up, you know. So have we got time for this? I've got this working. Anyone want to see H2O, what that looks like in practice? Yeah? Yes. All right, cool. So I have a Python example. There's two parts to this. The first part is the creating of the model. Can you see that? Let's make it, maybe I need to do the presentation mode thing.
We will make the same kind of
visibility. See it? Should there be presentation mode in there?
No one will understand. But
Crap, I can't see it. Can you see this? Or is that too far away? You need binoculars or something?
See it real far. This is large. 4 pages. You can bring this
Do you see presentation mode? Yes. Okay. For the hard of seeing. There. And that's the wrong one, isn't it?
assignment 3.
There we go. All right. So this is the famous iris data set. This is kind of a toy example, but I chose it because everyone's familiar with it, right? So this is the flowers. I have 3 different species of flower, Setosa, Virginica, and the other one. And so look, H2O, Python, you just import your H2O module. This AutoML thing is magic. So what it will do, what we do here, we import the data and we split it up into train and test. You've always got to do that because otherwise you'll end up with an overfit model, right? If you don't split your data. Yeah? So you split it up into train and test, and then you remove the thing you're trying to predict. And then you give it to this thing, and you can set that number to whatever you want. AutoML is going to try all sorts of different models and pick parameters for them and just randomly iterate, and it creates this thing called a leaderboard, and you just leave it for as long as you want, and then it gets you pretty close. Like, you're never going to win a Kaggle contest with this because someone else is going to do that plus a tiny little bit, but you'll get quite close with almost no effort, and I think that's gold, isn't it? So yeah, so look, here's the leaderboard, and then, so this thing here is the secret to moving from your Python script into production. A Mojo is a model object optimized. So it's basically got all the parameters of your model object, and you stick it in some file, and in this case, I put it in my Java program, and then I can just pull it in and start classifying records. And I think I have this running, and you can see it. So on the Java side, I don't know, this might be a bit of a, can we do that? That damn, where's the presentation mode? I don't know. Looking at Java code's no fun. All right, let's not. But do you want to look at the Java code? No? I say no, let's not. What's the time? Have we got time? 4:40. 4:40. I think no, let's not look at Java code. But it's on my GitHub. If you want, you can download it. And if this comes up for anyone and you want to sort of double click on that, we can connect. I'll put my LinkedIn and my Twitter at the end, and then if it floats your boat, then reach out. All right, so here we are. Couple more examples. This is something, tracking things that change. So I came from a supply chain background. I kind of copied my brother because I had no idea what I wanted to do. And then I realized, like, supply chain is super boring. But this was kind of a fun idea, supply chain idea. There's this thing that Li, he's a famous professor of supply chain, came up with this thing called the Bullwhip effect. And supply chain is all about end-to-end visibility, right? And so what the point of this is babies all over the place are shitting in diapers. And Procter & Gamble can't see it. Now, if Procter & Gamble could see every poop as it's happening, they can use that to adjust their manufacturing, and that can save them a lot of money. And so, then I happened to be working for this electronics company who rhymes with schmarrow, and this was a competitor of ours. And so one day, DigiKey, they carry such a breadth of inventory, right? Like 1.8 million items, and Arrow carries like 200,000. And I have to decide what to put on the shelf and how much to charge for it. And so one day I'm looking at this page, and it was almost kind of by accident, right? I crawled this. I wrote like a little Python crawler. I see, look, 1,638 units on the shelf. And then I go back a week later and I crawl and I do a little VLOOKUP in Excel, and I'm like, Jesus, they just gave me their freaking sales. I couldn't believe it. Like just watching that number change, and then I thought, oh wow, so there's this company and there's every other company that sells electronic parts. So I just went nuts writing crawlers, and so this is what I did. But there is a legit use to this. The Bullwhip is where is a legitimate use. So imagine your Texas Instruments chip makers have this thing called a fab. It looks a little bit like a CD-ROM or something like that. It's about this big. It has loads of little positions on it. So when they make chips, they need a clean room. They don't make them one at a time. They make them like 5,000 at a time on one of these fabs. And so to set this up is a very expensive process. So they'll introduce a part, and they'll get a report. Texas Instruments will get a report from DigiKey a whole month later. So a brand new thing. How many fabs should I take up? I don't know. We'll find out in a month. So I think that is the legit use for this thing. Yeah. So if you want to see how the sausage is made, I can show you the gist of it. You have to. If you're going to collect information at scale, you have to use proxies and all that. So that was kind of interesting. You can make your page requests appear from all over the place, and you just use a proxy. Yeah. So the point in this, we're talking about things that change being interesting, right? So numbers that change should track them. So behind the scenes, I use something called RocksDB to keep the state. Yeah. Anyway. This was another thing that changed. So the other day, I was poking around on the interwebs, and I see that RTD, and I can't remember what it stands for, but I think of it as Regional Transportation of Denver?
Regional Transportation District.
I think the Regional Transport of Denver is a better name. But I'm just kidding. Yeah, so anyway, the RTD has this feed of where all their buses are in real time. And you can poll it every 30 seconds. And that actually gives, I've got a YouTube on this, YouTube video, and there's code on the GitHub if you want it. But basically, I've got a Spring app here, polling this every 30 seconds, and it grabs this. And from that, from a lat long and a timestamp, there's this thing called haversine distance. There's a formula. You just Google haversine, and it's the distance between 2 points. So when you've got 2 points, you've also got the distance, the time difference, right? So you've got a distance and time. Distance over time is speed. So then you've got miles per hour. And then you can plot it. And this, I think, if there's ever a great way to fake productivity, is to plot things on a map. So people look at this. That's a pro tip, right? You could show, your boss walks past and it's all like code, and he's like, oh yeah, loser. But you show him this, it's like, oh wow, that's really cool, even though it doesn't really, whatever. Yeah. So this is the speed of all the buses around Denver, and I think it's quite an interesting leak of information that you could do other things. You can see where traffic is. I made geohashes of all the point. A geohash is like a little hexagon, and you can divide the world up into hexagons, and then you can say how fast the buses go through each one of those hexagons, and then you can do an anomaly detection. Oh, you know, people normally only do 10 miles an hour through this little dangerous bit, but this guy did 50, you know, so that sort of thing. But it's out there, and I thought it's kind of fun. Yeah. All right, we're getting there. So the last bit that because some of this is a little creepy, right? And I thought it's worth sort of mentioning a couple of things here. New York released 173 million taxi journeys, and they anonymized them. They used like MD5 hash and of the driver, and said, oh, that's good. No one can do anything with that. Just yeah. And so it turns out that there's this thing called EXIF. And I can't remember what it stands for, but I think of it as extra information. It doesn't mean, that's, yeah. So EXIF, this is Python. You give it a JPEG, and it will spit back, you know, where it was taken, all the camera settings and all that kind of stuff. And a tip, if anyone has nice camera equipment, set your copyright. A guy recently had his camera stolen, and the arsehole who stole it didn't change the copyright information. They was able to track him down. So that was a pro tip there. Anyway, so this taxi data set, like this is Bradley Cooper getting in a taxi. You can just query, oh, is at this time, at this place, where's he going? And then you can figure out where all people are going. And then it turns out that there's a whole bunch of douchebags who go to like a dirty old man's club or whatever, and then get taxis home. And this is a digital trail that's out there in the public of everyone who went to the gentleman's club. So I think that's kind of a funny unexpected leak there. Yeah. So anyway, this is ad tech. There's this thing called Loom Escape. This company specializes in tracking who's going to get acquired. And people who work in this space, like it's your dream to get acquired because you all get rich. And so I think it's kind of lame, but it shows who's who, right? And look at all these players. There's so many players. The ones that are interesting to me are these. Data suppliers, Equifax. Don't forget to ask for your $120 or whatever it is. For them giving all your information away, right? You hear about that? Yeah, so Equifax and all of these other players, and there are many, be honest, collect all your information, and then these guys sell it and trade it and what have you. So there's a whole business around like collecting all of this stuff and putting it together. And so I'm playing around with my phone, and yeah, these are all the players you can see. Some of them are even local, like, I don't know, I used to work for one. I pulled up an app. Why anyone would need a flashlight app on their phone is beyond me. Every phone has like flashlight, but there is an app, and look, it wants to know where you are. So right now, they know if you've been visiting the strip club. Yeah. Isn't that crazy? Yeah, and they're a flashlight. Why does a flashlight? Yeah. Yeah, it's crazy, yeah. Anyway, so this is highly recommended viewing. If anyone's seen this, it's a South Park episode. It's called Human Centipede. And the idea is, there's a movie called Human Centipede where people have one continuous gastrointestinal tract from one to the other. And people don't read those agreements, right? So you pull up your iPad and it's, where's the freaking accept button? Oh, and then you click accept. And then all of a sudden, you don't know what you agreed to. So that's a brilliant South Park episode. I think this leads to this. So you've got, Cambridge Analytica, the ultimate douchebag company, and this is the problem that leads to that. And that's it. Any questions?
Thank our speaker. Okay, now that all of you are frightened about technology, cybersecurity, and policy, and you've seen streaming data, questions, comments, assertions? Here.
I was going to ask, in terms of LPR, what do you think about outsourcing surveillance to companies actively monitoring U.S. data that aren't necessarily based in the U.S.? And what are the most, to give security measures these companies must take in order to maintain overall operational integrity?
I don't know. I think that is a law enforcement type thing, and it shouldn't go out of the country. But that's just my personal opinion. And I did work in that space, and I know that those guys were very, very secretive about where their data went. So I think that data, that LPR data, will absolutely not leave the law enforcement data center under any circumstances. But it does kind of beg the question. So I don't know if you guys were around when Jessica Ridgway, anyone remember who she is? It was an absolutely heinous crime. This little girl, she went to my wife's school. She got chopped up into little pieces, and everyone in the neighborhood's freaking out. And then I'm driving down the street, and I see a flash behind me, and I thought, wow, what was that? I wasn't going fast. And then it turns out that people who do horrible things often go back, and then you can start collecting all of these license plates. And then I was thinking, I just reached out to the ALPR company, and I have cameras. In fact, that facial recognition thing, I had that running in my house for a while, and my wife came home and was like, what? Do we have to have a camera looking at us the whole time? And just make it go away. So I made it go away. But anyway, my point is that ALPR, you can put them everywhere, so it's not just the domain of the police. That's for everyone who wants it, technology. Yeah. Yeah.
Further questions, comments, concerns? So how do I protect myself? I want privacy. You just told me that if I have a camera, a phone with a flashlight, and I happen to go to an old person's club, then I'm going to be in deep trouble because I can be followed. So how do I protect myself?
Everything is-
I mean, it's not anonymized.
A burner phone. I don't know. Yeah, I think don't do social media. Read the things. I know no one wants to read that. I put. There's actually a dictionary of legal bullshit. That is a real thing. I can't go back now. But there's you know when there's loaded terms. People use like in the colour of law. That's a little term that says kind of I'm a law enforcement official that's acting under my own authority. But there's a gazillion like silly terms like that. So when you open up one of those contracts, it's just like, it's incomprehensible, right? So you have to scroll to the bottom and just move on.
But,
That's it.
but if you don't opt in,
Yeah, you could not have an iPad. You could
cannot have an iPad. You can't participate in the future that involves technology, cybersecurity, and policy. And so,
I don't know. I don't have a good answer for you. I'm sorry. Yeah.
Okay, yes, question?
So you currently work at Confluence, right?
Yeah. Confluence.
And then you mentioned some other companies you work
Yeah.
at. Did you start the company? Was it another guy?
No, it's like 700 people. I'm a peon. I'm like,
Okay.
yeah. Between me and the CEO,
was trying to get
it's like 11 people or
And
something.
then that product, Kafka, were you involved in the development of
No,
that?
that was in 2011. It was developed at LinkedIn, and so this is a really common pattern for.
Okay. Gotcha. You said the open source version of that is Debezium?
No, Debezium is a CDC tool. Kafka is basically a message queue.
Right.
There's more to it than just being a message queue. There's getting data in, there's stream processing, but yeah, in essence, the message queue is what it's most well known for.
I guess I was interested in the open source version of Kafka that was developed at LinkedIn. Tell me more about that.
Yeah, so that is an Apache project. You can just download it and use it at massive scale, whatever. Even 3 crappy machines. So if you spin up 3 cheap machines on AWS, you can get like 1 million transactions per second. So that it really is. It's sweet spot. Sweet spot is fan out. Do you know what fan out is? Have you heard of that? So a fan out means I've got more reads than writes. So I write some data. The way it works. Oh, look, imagine you've got a queue. This is a queue of messages like this. And you have 3 consumers, so you have 1 queue, but maybe I'm here, I'm consuming this data from here, and I'm doing sequential reads, and my colleague is like here, but you have 1 queue. That's the point. You have this thing is distributed across lots of machines, and it uses something called page cache. I don't know if you're into the sort of guts of Linux, but the page cache caches things that are being read from disk in memory, and it will write directly from the page cache to the network, and that's the secret for getting all this bandwidth. that's why it's so fast, right? It just stores this information once. Most of it gets stored in memory, and it can be read by many, many things at once. Yeah.
One last question.
Kafka, why Kafka?
Yes.
Because the guy, Jay Krebs, the 11 ranks above me, he said he had recently read The Metamorphosis. You know that book? Yeah. So Franz Kafka, it's about a guy who turns into a cockroach. And he said that Kafka guy, he writes pretty well. And so this is very good at writing, right? Kafka's writing to logs, he'll write all day, spread out over lots of machines fast. And so that's why it's called Kafka.
Technology, cybersecurity, policy, and
Kafka.
literature. So please, let's thank our speaker. And of course, you all know what the assignments are. 511 words and with 4 square roots, et cetera, et cetera. And so I look forward to reading the documents. So thank you all, and I think the due date for this project is it
Monday.
Monday. Thanks, Will. And so it's Monday, and so you have time to review the video. We're hoping to have it up within the next day. And so thank you all for coming, and thank you for the questions, et cetera, et cetera, et cetera. And see you next week. And please thank our speaker one more time.
I don't get you.
We already have one.